I head up marketing for Avi Networks, and today I'm joined by Ashish Shah, who's Director of Product Management here at Avi Networks. Thank you so much for taking the time to join this webinar. Today we're going to keep this really factual and simple. Although I head up marketing, I promise I'm going to stay away from any marketing hyperbole and just focus on the 7 tough questions that our customers are asking us when we go try and sell them our load balancer. And a lot has changed over the last few years. I mean, some of the big disruptions that are happening in the industry with cloud and mobile and a move to a microservices-based architectures have fundamentally made the legacy solutions not ideal for the situations that our customers are in today. So with that as the backdrop, I thought we'll just have a straight talk discussion about the top 7 requirements that we're hearing from our customers that are looking to buy a new load balancer. So like I said, a lot of changes are happening with clouds and microservices and mobile becoming the dominant access point for for accessing applications. And so the legacy solutions are really not cutting it anymore. So with that, here's the 7 questions that we get asked, and I'd like to share some of these with you and get Ashish's thoughts on those. So since this is a pretty lengthy topic, we're going to cover 4 of the 7 in this webinar, and then the other 3 a couple of weeks from now around security, multi-tenancy, and integration. But today, the topics we're going to focus on are self-service provisioning, elastic scale, how to get rid of proprietary hardware-based appliances, and then application visibility. Before we get into it, I'll just give a 30-second introduction about who is Avi Networks. We're a software networking company based in the Silicon Valley in Santa Clara. We've been around for about 3 years. We've been shipping product for about a year now, and at this point we have about 25 customers. Exclusively focused so far on Fortune 1000 customers, but we're seeing a lot of traction in the mid-market and smaller customer segments as well. What we've built is a software load balancer with integrated application analytics. And we're going to show you a demonstration of our product, so all of the analytics stuff is going to become really clear. Talking about our customers, unfortunately, because of the red tape in a lot of these organizations, I can't tell you the names of each of these customers. So this is the best I can do. We've got a top 3 US cable provider, a top 5 bank in the US, a really large global service provider, and a top 5 US e-commerce vendor. I know that's not ideal, but unfortunately, like I said, with the red tape issues, this is the best I can do for now. Avi was formed based on these 3 core design principles, and this is how we differentiate compared to some of the other legacy solutions in the industry. We're the first distributed software load balancer. We follow SDN-like design, so we've got a centralized controller and an elastic distributed data plane, which we call service engines that provide the load balancing and analytics services. We're also the first load balancing company that takes the real-time data from users, devices, applications, the ambient state of the network, and uses all of this to calculate what we call inline analytics to optimize the load balancing and security functions in runtime. And from a pricing perspective, we don't charge based on bandwidth per second. We charge based on the number of applications that we actually load balance. And it's a consumption-based model, so our customers don't need to pay huge capex upfront. They pay for the services that they actually use. So with that, let's get into the first tough question. So, Ashish, you want to say hello to our attendees here?
Hello, everyone. Hope you're doing well.
So the first question, and I hear this a lot, Ashish, and you hear this a lot in talking to customers, and this term called self-service provisioning comes out a lot. The ability for non-networking experts to use an ADC, not have to rely on the network administrators. Is that sort of what we mean here by self-service provisioning?
That's right, Didi. Most of these enterprises are driving, the goal of these enterprises is to drive application deployment as fast as possible. And so if you have to create tickets for creating a load balancing instance, that's really impacting your application deployment and delivery efficiency. I was at a bank a couple of weeks back in New York, and I was astonished to hear that it takes about 27 days on average from the time that application developer requests a load balancing instance to the central IT team actually delivering that. Imagine an AWS-like experience when anybody, an app developer, can go down to a portal, create a load balancing instance in under 30 seconds, and eliminate your network tickets and twice fast your application deployment time frame.
I think that's a really good point. We know a lot of large enterprise customers, banks, retail, etc. They're all trying to emulate and replicate the AWS-like experience in-house. And the other fancy word for this is private cloud. And so these developers need access to these network resources instantly. So tell us a little bit about how Avi is making this possible, and how some of the legacy solutions were not really designed for this internal developer private cloud.
That's right, Didi. So the first thing you need is 100% REST APIs, because that's the only way you can have the self-service portal which can automate the entire creation of load balancing instance creation. With Avi's architecture, which is a centralized controller-based architecture, the controller provides a single point of automation where the self-service portal can be built through the REST APIs. Compare that to the legacy appliances where you have a hodgepodge of different interfaces. You have some features available only through CLI, some through UI, some through SOAP or REST APIs. So there is no single interface through which you can automate the entire environment. The second aspect of that is the automation that the Avi controller brings in through the centralized controller. The centralized controller is single logical ADC that can scale to whatever capacity you need. Then it talks to vCenter, talks to AWS, talks to OpenStack to spin up these load balancers without networking experts. Right? Today, the challenge with the networking legacy devices is that you have hundreds of these devices that you need networking experts to manage, because you need to figure out which one has additional capacity, how they have to be plumbed in the network, and so on.
Right. So I think there's benefits both for the developers themselves. They can just use their API interfaces, fire up a load balancer in less than 30 seconds.
Right.
And the benefit for the network administrators is still that they get the entire visibility over the entire infrastructure. And I think the key is the 100% REST API and this SDN-like architecture with a centralized controller.
That's right.
Can you show us what it looks like?
Sure, yeah. Let me just get out of these slides and move to my Avi UI. So what I'm logged into is the Avi UI, which is built on top of REST API on top of our controller. And first thing you see is a color-coded health score-based applications. If I'm an application developer and I want to create a new load balancer in a self-service fashion, all I have to do is click on a couple of places. So start with a basic wizard. Let's give this a name for my application. I'm going to call it self-service demo. And then I need to give the RIP IP address, or in this case, I have my application which is named by myself, Ashish. It goes to the DNS, picks up the IP address. Mm-hmm. I've completed my front-end configuration in 10 seconds. Mm-hmm. Next, I'm ready to configure my backend servers, my pool servers. Here, I can choose to type in manually, but instead, what I'm going to do is my controller is talking to the vCenter, picking up all the networks which are available. I know which network my application is running on. In this case, it's running on VLAN 100. Okay. I see a bunch of VMs which are running. Again, our Avi controller is picking this up from the vCenter. I know I want to load balance Apache web servers. I type in that, I select, add, and I press save. At this point, my load balancer is ready. I didn't have to type in IP addresses manually. I didn't have to create a ticket. Compare 30-second experience to a 27-day experience. So
what you just did is essentially what's taking a lot of these large organizations, days and weeks to provision.
Exactly. And as a result, the application developers are going to AWS and say, I want an ELB-like experience. Well, that's what Avi has delivered on an on-prem data center.
Now, I know you showed all of this on the Avi UI, but what if if somebody did not want to use the UI? How would a developer do all of this that you just showed me?
So everything that you saw was through REST APIs. Avi UI is built on REST APIs. So many of our customers have built their custom dashboards or integrated with the rest of the orchestration systems. And through the APIs, they drive the self-service portal.
I guess that's why you put this quote in here, which we hear from our customers all the time. REST APIs ought to be treated as first-class citizens.
Exactly.
Thank you so much. So that's the end of the first tough question that we get in these environments. Let's move on to the next one. So I hear about this a lot, and these different words used for describing elastic scale, dynamic scale, on-demand resources. Why is it so important, Ashish, that, why is this elasticity, not just the ability to provide huge scale, which is what I hear of a lot from, some of the other vendors, but why is this elasticity so important?
One word, Didi, agility.
Okay.
It's the business agility which is the primary factor for these enterprises to have an elastically scalable experience. Imagine you are a retailer and you have a Black Friday or a Cyber Monday environment. On a normal day, which is not a holiday period, you're running 2 gigabits per second, for example, for your network traffic. But as you approach the holiday period, you're scaling up to 10 or even 20 gigabits per second.
Mm-hmm.
As we were talking to a retail customer, the challenge he faces in such an environment is that he has to provision for the peak.
Mm-hmm.
He has to provision 20 gigs per second for the peak, combine that with HA spare. Now you're provisioning 40 gig capacity for a day-to-day traffic of 2 gigabits per second. That's a waste of resources, money, and operational complexity.
Right, but I guess they do it today because they don't want to lose their jobs, right?
That's right.
So, it's not just the ability to provision everything in advance, but then to turn on the capacity on the fly. I think we looked at the trouble ticket situation in the previous example. So I think what they're looking for, if it takes 30 seconds to fire up a virtual machine, I should be able to fire up a load balancer in the same amount of time, right?
Exactly. They want that AWS ELB experience.
And
as my tenants grow, as my applications grow, as my real-time traffic grows, I want my load balancer to scale out on demand automatically. I don't need to worry about capacity pre-provisioning. I want my infrastructure to automatically take care of my application SLAs.
Makes sense. So how does Avi do it, and why is it that legacy solutions cannot deliver this elasticity?
So I think the fundamental reason is the way Avi's architecture has been built, which is in layer 4 to layer 7 SDN architecture based on a centralized controller and distributed data plane. We call them distributed microservices. As what happens with the centralized controller is that it's running real-time traffic analytics and looking at available application requirements and resource capacity and on-demand scaling out the distributed data plane as the traffic grows. Compare that to the legacy infrastructure where you have no single point of control. You have multitude of devices which don't have pool capacity, and all of them are discrete, that you cannot really scale on demand. You need to buy a new appliance, provision it, and manually configure it. That's the reason.
So, I'm just looking at this chart that we looked at before. I think it's the picture on the top left. I think what you're saying is we've got a centralized architecture that can have then, spin up these micro load balancers, whether it's in your on-premise data center, a private cloud, multiple private clouds, and even public clouds like AWS.
That's right.
Because the micro load balancer, what we're calling the Avi service engine, that can be distributed and can elastically scale within and across these locations. But from a management complexity perspective, you're always managing a single device, which is the Avi controller. That's excellent, Ashish. Can you show us this
so
scale in
let me
action?
go back to my dashboard here and let me look at one of the applications here. So let me move to a real-time time frame with the traffic that I'm running on this load balancer. So as you can see here, I'm running about 200, 300 Mbps of traffic. Now, there are two ways that Avi can scale. One is an automated scale, where based on pre-configured thresholds such as bandwidth, latency, CPU utilization, and so on, Avi controller can automatically spin up new instances on demand. For the purpose of the demo, to keep it simple, I'm going to do a one-click scale out. So in this case, I have this application which is running on one service engine, as you can see here.
So that's one micro load
One
balancer.
micro load balancer, exactly.
Right.
And if I click on a button called scale out, at this point, the Avi controller is talking to the vCenter, either spinning up a new service engine or a VM, or if there is an existing VM, it puts it in the right network. And as you can see, while we were talking, it scaled out from one micro load balancers to two. And again, the traffic almost doubles as we add additional capacity. So this is the power of Avi's controller-based architecture, where it can elastically scale to give you an Amazon ELB-like experience.
So let me understand. Both of these load balancers are running, now you've got two instances,
That's
right?
right.
Both of these are running inside virtual machines, but you just hit that button called scale out. Who configured that second load balancer? How did it get its credentials, the state, all of that? How did that happen?
Excellent question. That's where Avi's controller comes into play. So
Okay.
Avi's controller is a central point of not just policy repository, but also control and management. So the Avi controller talked to vCenter to either spin up a new virtual machine or reconfigure that to put in the right network. It downloaded all the policies that we needed for these applications, and it started serving the application instantly.
Great. So I guess since in case of the Avi solution, you've got the centralized policy database and a centralized point of automation and control, we can make all of this possible. But in case of discrete appliances, which each have its own policy database, has its own control plane, it's literally impossible to do this kind of elastic scaling on the fly.
That's exactly right. And there was an interesting question while we were speaking, which is, do you maintain the session persistence before after you scaled out? The answer is absolutely. The sessions which were already active on the previous micro load balancers continue to go there.
That's
the new
excellent.
sessions then go out to the second load balancer.
All right. Thanks. So let's look at the third one. So this is what I hear about a lot, and I don't know if we guys all hear about software-defined networking, software-defined infrastructure, software-defined everything.
Yes.
Like Mark Andreessen said, software is eating up the world. So now the big desire, I guess, I hear from customers is they don't want to keep adding new proprietary appliances, hardware-based appliances. Can you tell us why? Why is that desire to just get rid of these proprietary appliances and just have everything served up on just standard x86-based infrastructure?
Absolutely. Again, it goes back to the concept of business agility. The customers are driving business applications and they want to accelerate time to value. They want to deploy these applications as fast as they can to drop the top line growth. Proprietary appliances actually prevent them from doing that because they have to order them, procure them, provision them, and they can't really scale elastically as we saw earlier. So what's driving this software-defined everything is the desire to be agile, to reduce operational complexity and drive automation.
Right. I think in addition to the fact that, if everybody's got ambient x86 capacity. So, somebody could just download the Avi software from our webpage and just use it on their existing servers without paying anything upfront. There's no upfront cost.
That's absolutely right.
Great. But, I do hear this objection, and maybe it's more of a religious argument here that, hardware is just perceived to be higher performant, higher resiliency compared to, software running on x86. Is there any truth there?
I think it's a myth. Intel has solved this problem some time back already. Intel's x86 architectures have kept up pace and they have delivered higher and higher performance over the last few years. If Google and Facebook can run their entire infrastructure and network services on x86 servers, why should enterprises be subjected to proprietary appliances?
I think that's a great point. So tell us a little bit about a fully loaded, or I should say fully instantiated Avi solution. What kind of performance numbers are we talking about? Not to scare anybody here.
Well, we can go to multi-terabits per second on a single instance of Avi solution. Again, with the centralized controller cluster for high availability, that is scaling out the distributed data plane, the x86-based VMs or containers on demand as the traffic grows. So we can scale up to multi-terabits per second.
And as Intel keeps bringing, higher performance, higher memory chips to the market, does that require any change on the software from Avi?
No, it's a standard x86 application. If your applications are running on servers, your network services can also run on servers, including SSL. Again, there's a myth that SSL requires proprietary hardware. Google's have debunked that myth long time back.
Great. So I guess, again, this is something we heard from one of our customers that to start, you give me pay as you go, as I start with Avi, but then as my requirements increase over time, I can keep paying as you grow without having to pay for these proprietary appliances.
Think of AWS experience for your on-premises data center.
That's great. All right, let's talk about the last one that we're going to talk about in this webinar, which is around application performance visibility. Now, data centers, clouds, private cloud, public clouds, they exist for just one simple reason, which is they all serve up the application. And the data center application is king. So I think it's crucial for not just an ADC, but a switch, a router, a server, everybody to know at all given points in time what changes, if there's what's actually what's happening to the application, and B, if any changes made on any of these devices, whether it's a server or load balancer, what have you, what it does in real time to the application performance.
That's right. So first point is that the ADC is in a very strategic position. It sits in line between the end users and the applications. So as the traffic goes through these the load balancers, you have all the analytics available to you. But with Avi, we go beyond that. So not only those micro load balancers, those service engines act as virtual probes, collecting hundreds of metrics every second. They actually feed into the big data analytics engine on the Avi controller to give you that real-time closed loop feedback. So as you mentioned, the bread and butter of an enterprise is the application. Being able to get application health in real time, to understand how your end user is experiencing the application. And when there is a problem, how quickly can you triage the problem? It's key. The second thing we hear from our customers is, today with their legacy devices, it's fire and hope that everything that they've configured is correct. There is no real-time feedback on whether the configuration they made is going to have a positive impact or a negative impact. With Avi, again, we have fixed that where we can get real-time feedback on what's happening to your applications based on your configuration change.
Right. No, that makes a lot of sense. I think let's stop the slides here and show our friends what some of this analytics that you're talking about.
Absolutely. So let's go back to our Avi UI. Let me go back to our dashboard and let me look at one of the applications.
First off, I got to say, this looks nothing like a load balancer console that I'm used to.
You're absolutely right, Didi. This is a next generation UI on top of a next generation load balancer that gives you that real-time feedback for your application performance.
Okay.
So the first thing you see is the application health score that gives you color-coded experience on how my application is doing, how end users are experiencing it, if there are any security or other issues along with that. But a very interesting dashboard that you should look at here is the end-to-end timing. Without any agents, without any span ports or monitoring fabric, this dashboard tells you what's the latency breakdown from my end users to the load balancer, which is typically in the data center, in this case 90 millisecond round trip, the WAN latency. What my local network latency is, it's 2 milliseconds or so. How long is the application taking to process this request on an average? It's about 126 milliseconds. And it takes a millisecond and a half for the data to go back. Imagine you're a network admin who always gets blamed for every problem in your application environment. Well, this is a mean time to innocence tool. By the way, this term has been coined by our customer. That you can quickly see here if there is a problem with your application performance, and if so, where it is. It's not always the network. In this case, it's the application latency which is the highest. So this is one type of analytics, the high-level troubleshooting dashboard that we give you. But we go beyond that. Imagine not doing TCP dumps anymore. Imagine you get a Google-like search experience for your network traffic. Well, that's exactly what Avi has built.
Okay.
So first of all, you can look at individual transactions in detail. So for example, if I look at one of these transactions or one of these transactions, you can say that this particular transaction came from Korea on somebody running Firefox on a Windows machine. Took 49 milliseconds to hit the data center. It must be a regional data center. It was received by these set of IP addresses and ports and was looking for a particular PNG file, and it was not found as a 404. So you can go into the level of individual transaction without running your TCP dump. Think of this as an HTTP dump, right? At your fingertips. The second thing you can do is, as I said, Google-like search. So for example, if I want to know that, what are my iPhone transactions? I just type iPhone.
Right.
And within seconds or less than a second, it showed me all the iPhone transactions. Let me see one of them. This looks interesting. So this particular person came from India. running on an iPhone running mobile Safari, and it looked for homepage, and it looked like the latency was pretty high. So these type of log analytics is very powerful. Now I'll end with one final example. Imagine you're a network admin and you want to look at the latency profile of your application. So let me clear the search and let me look at the end-to-end bar chart of my applications. So in this case, I clicked on the end-to-end button on my dashboard, and it's populating this with the latency breakdown of all the transactions over the last 6 hours. What you observe very quickly is that most of these transactions are sub 100 milliseconds, some are a couple hundred milliseconds. But there are some isolated cases which are very high, which have very high latency. So let's click on those. As I click on that, my query got populated with that particular search. Now I have a bunch of these transactions, and now I can do second order analytics. Are they coming from a specific browser? So let me see if they're coming from a specific browser. Not the case. Are they coming from a specific location? Looks like yes. So in this case, all the users in India are experiencing very high latency.
Right.
I can go back to now my network admin or my local data center in India and say, why don't you look at your WAN, or why don't you look at your local network configuration to see why there is high latency?
Sure.
So this type of troubleshooting is unheard of for today's ADC appliances. What today you have to do is have a separate monitoring fabric or agents in the application to be able to get you this level of visibility that Avi gives.
Right. There's obviously tools in the marketplace that do all this kind of analytics, but I see two problems with them. One is it's managed, procured in a completely separate department, and those guys are completely siloed from the network administrators that are managing the ADCs.
Right.
And the only way of interaction between these two teams is through trouble tickets, which we know is not optimal.
And finger pointing.
Right. So which we know is not optimal. But I think the other thing that I like is the way you're presenting this information, right? I mean, it's not like ADCs do not have this information, but it's sifting through, hundreds of lines of logs and alerts and things like that. But this is very intuitive for me to see, A, what my application is doing, and B, if there's something wrong with the application, being able to immediately root cause and pinpoint the source of that issue. So that's great. So folks, we covered the top four, and hopefully this acted as an appetizer for you for attending our next webinar, where we're going to cover the next three, which is the kind of security, multi-tenancy, and integration within ecosystems that we see in the marketplace today, whether it's VMware, whether it's OpenStack, whether it's SDN controllers from Cisco or VMware or some of the other vendors. And there's nuances in how Avi brings unique differentiators to each of these. Now, I know there's a few questions that have come online. Ashish, do you want to just quickly address them?
Yes. So I think we talked about one question about session persistence already. Let's take the next question, which is about how is the traffic shared across different SE instances. So you can do multiple different ways. You can do BGP based with route
now,
health
SEs
injection.
are service engines, which is the micro load balancer, right?
That's right. So
okay.
Thank you. So there's a question about how the traffic scaled across multiple service engines. There are multiple ways to do that, including support for BGP, for ECMP. We can do global load balancing, or there are other mechanisms that we have, and we can reach out to if you need specific details that can share traffic across multiple SEs. There's one more question about how do you, what are the requirements for your service engines in terms of CPU memory as you scale? Now, clearly, the more CPU and memory you give, the more performance it gets. You can start with as low as, on your service engine, 2 gigs of memory and 2 vCPU cores, and you can give it a full 16-core server if you want to get tens of gigs of performance out of a single server.
I think all of this is documented in our performance data sheet. Why
That's
don't we
right.
send that to our attendees right after this call?
Sounds good.
So folks, again, thank you so much for your time. And like I said, these are the tough questions that we're getting from our customers. And so we thought, if you're in the market looking for an ADC or a load balancer, take this checklist and ask your ADC vendor if they how they score on each of these 7 parameters. So with that, hope to see you in a couple of weeks. I want to thank you, Ashish, and thanks to all of you attending this webinar. Have a great day.
Thank you.